Thank you. My name is Yuji Akutsu, president of Sodick Inc. First, I'd like to say Sodick is a leader of technology in machine tool industrial. Here, our new product, OPM250L, is our natural development of a product. At this moment, we focus in multi-customers in the US market. And in near future, we move to other industries such as aerospace. Today, we have a new OPM250L customer in this market, Phoenix DeVentures. This is Jeff Christian, CEO. He will explain about our advantage of our product. Also, you are like a more applications and utilizing our OPM250L. And I'd like to say thank you so much for choosing our new product.
Well, thank you. Can this be heard okay?
Yeah.
Okay. There's a lot of noise back here, so a little louder?
Yeah.
Okay. Well, as Mr. Akutsu said, my name is Jeff Christian. I'm CEO of Phoenix DeVentures. We're located in Morgan Hill, California, just south of the Bay Area in Northern California. I founded Phoenix DeVentures almost 16 years ago. We are focused in the med tech industry. We develop and manufacture medical products, everything ranging from surgical instruments to spine and heart implants, implants for the eye, and a lot of different medical technology-related products. In order to appreciate why I made this commitment, and I will not trivialize this, this is a big commitment for a small company. The reason I made this commitment is this. I have been following and using 3D printing for 20 years. I first bought a 3D printer. It was a Stratasys machine 20 years ago when I was vice president of development at another med tech company. And having 3D printing in-house revolutionized the engineering process. We would design product concepts, build prototypes, test them, use them in surgery, and the turnaround time of rapid iteration of ideas was revolutionized through 3D printing. So when I founded Phoenix DeVentures, one of the first things I did, frankly, in that company, I found it in my garage. So in my garage, I had a machine shop, I had injection molding, and I bought another Stratasys 3D printer. So I've been tracking 3D printing for the last 20 years, always interested in what was new, looking for the time when resolution would improve and materials would improve. And so about 8 years ago, I bought what then was the Next Wave 3D printer, which offered improved resolution with stronger materials, so that when I would build prototypes of our design concepts, I had real functional designs that I could fit, test, and so on. But in my mind, I was always waiting for the time when 3D printing became viable in metal. Well, about that time, a German company, EOS, did develop a viable technology in 3D printing metals. And 3 years ago, I did buy an EOS machine. Okay, and I've had that machine functioning for nearly 3 years now. We have in-house mold making and injection molding. And the EOS was a revolutionary change for us, or I should say the laser sintering of metal. The biggest revolution, as was mentioned by the previous speaker, was that conformal cooling became a reality. And to anyone in injection molding, you'll understand that what this means is when she talked about reduction of cycle time by 21%, we've actually had greater reductions than that. Our greatest account so far in reducing cycle time was a 50% reduction in cycle time of molded parts. Now what does that mean? That means next year I don't need to buy more molding presses. But the downside of laser sintering is that the surface finish of laser sintered metal is pretty rough. And you'll see several examples here on the tables of parts that were laser sintered, leaving surfaces that were pretty rough, meaning not finished until now. So we found that in making molds with laser sintering brought us the great advantage of improved cooling through conformal cooling, but we still had to do significant post-processing of the mold. A lot of handwork, finished machining, a lot of EDM work, and so it really didn't reduce the time to make a mold until now. So about 2 years ago, Mr. Akitsu and others from Sodick visited me to get my view on the laser sintering process for making molds. And in this time, other things have evolved, which has heightened the criticality and importance of all the molds. In parallel with looking for metal printed capabilities, I was waiting for traditional 3D printing capabilities to increase to the point where I could print injection molds. Last year that came to reality. There's a couple countries that made printers with improved materials. We bought a new, over a year ago, a printer that would print plastic parts that were strong enough, with high enough heat capacity for us to print prototype injection molds. We call them engineering molds. We shoot parts, we test the parts, we throw the molds away. We'll get 100 pieces of them, we'll throw them away. More importantly now, I can use that same concept in making these molds in metal. And I don't have to throw them away because they aren't going to break after 50 or 100 parts. Okay? So we've had the machine for only 1 month. And I will say that it's much more sophisticated than other technologies, and therefore the learning curve is a bit more complex. Brian here right in front is my engineer that I gave him the responsibility for this, and he's done a great job learning very quickly, bringing that learning curve down as rapidly as possible. And the first thing that we did when we got the machine installed is we built a mold, a small mold, just the inserts, for a mold that we had previously built with laser sintering of metal, but then had to do all the finished work afterward. And that mold took an overnight process of laser sintering and then 3 man-days of post-processing finishing. We built a copy of it on this machine. It took 15 hours total with no post-processing finishing. 4 man-days, actually 15 hours plus 3 man-days, reduced down to a total of 15 hours total done. We then have done other small molds, learning the software and the process and so on, until last week we built our first real mold, a 2-cavity mold of a housing for a respirator unit, which we built the mold for, and I'm about to tell you what I think is the most significant contributor to the contribution of this technology, besides the conformal cooling. We built conformal cooling into this tool so we can bring cycle times down. But in addition, and here's the big advantage, normally we might have used as many as between 6 and 10 EDM electrodes for some of the features in this mold. We did this mold complete with 0 electrodes. 0 electrodes. Now, those of you here who are either mold designers or mold makers or managers of mold shops, you know that EDM, especially for complex parts with a lot of ribs and so on, the EDM work on a mold could easily be 50% of the cost of a mold, right? We built this 2-cavity mold with 0 electrodes. And We took it off the molding press. We only then assembled the mold, fitted it, put it in, and shot parts. That is revolutionary. Now, let me show you an example. I did a lot of research into this, by the way, before I committed to this machine, because I'm a small shop. I've got 60 employees, 4 mold makers. We're a small shop. For me to make this kind of commitment is not trivial. So I took Ryan and the manager of the mold shop to Japan, and we visited 3 sites, one in Kyoto, one in Tokyo, and one in Miyazaki. In Miyazaki, we visited a molding shop, a Sodick subsidiary, making automotive connectors. And I observed them making a copy of this mold. Now this mold, because they make millions of parts, they have several molds running all the time. This is a mold which previously was built, I believe it was 31 components, individually machined and assembled to build this core of this part. This mold, and you'll see this, it'll be on this table afterwards, this mold was made in a single insert with no EDM work. When I say a single insert, it was built on the OPM in, what was the total time? Refresh my memory, 50 hours I think it was. 50 hours of machine time on the OPM versus, I believe it was 2 or 3 times that to make the individual components and then assemble. Is that about right, Brian? When I saw this and saw the reduction of the EDM time, that's when I knew that this was the machine for my little shop, because quick turn is very important to us. Being able to do all the complex features for our components is crucial to our customers, and I can't always make plastic molds and throw those molds away. I have to be able to build production level molds. That's what convinced me that this technology is the mold making tool of the future. I committed to it, and I'm glad I did. We've only had it for a month, but it is already proving itself to be exactly what I had anticipated it would be. Kind of the accumulation of all the advantages of 3D printing now married to machining, so that coming off the machine is finished. Now, we still have a lot of things to learn. We're looking for ways to improve our skills in using this tool, as will be the case with any complex tool. If you're going to commit to this machine, realize you're going to have a learning curve, but it will pay off for you. This is a very serious, great tool, and that's why I committed to it. Frankly, I anticipate a couple more over the next few years. That's how I see this technology going. I'm open to any questions. I probably skirted around some issues in this brief time. If you have any questions, I'd be happy to answer them either now or afterwards. If you want to come up, and I'd be happy to answer them. But I appreciate the opportunity to talk about this. When I see a technology I believe in, I want to help that technology go. I am not married to Sodick, but they make great machines and they're good people. And so I'm happy to have struck this relationship with them.
Thank you, Jeff. Can I hire you as a sales of Sodick? I'd like to hire you as a salesperson.
So this is a bit symbolic, but we have here what we're signing is the equipment purchase agreement. Even though I already have the machine in my shop, this is a symbolic gesture. We can run these machines, but I can't run a pen.
Let's talk. Kanpai, cheers. Thank you for this.